Welcome back. I'm not entirely certain where the video cut off. So remember, there was an example. We were looking for the equation of a line through 3 points. Notice if we hold x constant, we can find n as the change in z over the change in y. If we hold y constant, then we can find m, which is the change in z divided by the change in x. You plug into the equation of a line. This is one of them. Add your point, and you can solve for c. And so the equation of the line would be minus x minus 2y plus 2 equals c. So let's try another example. Actually, I do want to be black. Let's try it. Oops. Oh. Need my tablet before I can write. Okay, so let's try another example. Plane passes through the points 0, 1, 5, 0, 4, 2, negative 1, 1, 1. Remember, as long as one variable is constant, we can find m and n easily. Okay, so let's see. Here's my pen. Here we go. Notice the x's are the same here. So using x equals 0, n is going to be the change in yikes, my pen. Change in z over the change in y. That's z. Should probably erase it, but there we go. Z. Okay, so change in z, 2 minus 5 over the change in y, 4 minus 1. And we get minus 3 over 3, which is negative 1. Okay. So this was using the same x coordinate. Okay, notice we have a 1 here, and a 1 right here. So that's the same y. So that's using the same x. So this will use the same y coordinate. That being that y equaled 1. So m will equal the change in z over the change in x. Okay, change in z. So I have 1 minus 5 divided by minus 1 minus 0. And so we get minus 4 over minus 1, which is 4. Okay. So we have to find c. Oops, that's a need to find c. What did I use? So let's just use the point 0, 1, 5, and we have y equals come on, y equals mx plus ny plus c. So I am going to use this point. So y is 1. Sorry. M is 4. X is 0. N is minus 1. Y is 1. Oh, sorry. So silly. That's a Z. And Z is 5. Plus C. So we get 5 equals, that's nothing, minus 1 plus C. Add the 1. And we get 6 equals C. So we get Z equals mx plus, oops, don't like that. Let's just go slowly. N is minus 1, which you don't need the 1, y, plus c, which is plus 6. Go. You can also, use the other equation, z minus z naught equals you have to multiply 2 out. Don't do that in this case. We don't need that. We don't need that. I'm going to erase that. You can. You can. You can use it. It's fine. So remember the other equation, z minus z naught equals mx minus x naught. Plus n y minus y naught. And usually this is just automatically brought over here as z naught plus m x minus x naught plus n y minus y naught. And so you can solve for the c that way, right? Because, might as well do it, I guess. Let's see. Z naught is 5 plus m is 4. X naught is 0, n is negative 1, and y is 1, so you would get z equals 5 plus 4x minus y plus 1, and z equals 6 plus 4x minus y. So you can use the other equation for a line, no problem, just depending on what you like to do. Okay, so what if I just asked, for the z-intercept? Right, so what's it mean to be an intercept? A z-intercept would cross the z-axis, and what are the other values? They would be 0. So we're searching for the point 0, 0, z. So z equals, x is 0, y is 0, 6, so you just get z is 6. So the z-intercept is 0, 0, 6. You can solve for other intercepts as well. Right? What is x-intercept? Well, we're searching for the x, and everything else is 0. Let's see, z is 0. You have 4x minus y plus 6. So you have minus 6 fourths equals x, and that's minus 3 halves. So the x-intercept would be minus 3 halves, 0, 0. Right. You can also find the y-intercept. Good. Lost my train of thought briefly. X and Z are 0, so you have to find the Y value. So Z is 0, X is 0. We have minus Y plus 6, so you would get minus 6 equals minus Y, or 6 equals Y. And so the y-intercept is 0, 6, 0. And there's the plane that passes through those points. Okay, so sometimes we don't have just points. You might have, oh, here was my handy dandy button. Come on, where is it? There we go. Something totally different. So, example, given the following table of values, find the function c plus mx plus ny. I'll be right back. Okay, so sometimes we have a table of values. So the x values are coming down here, 10, 20, 30, 40. Y are going up here, 10, 20, 30, 40. And inside are all the z values. Okay. So m, remember, is the change in z over the change in x. And that's with the change in y constant. So pick a y, so right here, let's just do this. Right, y is constant, and I have my z values and my x values. So I would get that m equals the change in z, so that's 2 to 3. Divided by the change in x, and that would be 20 minus 10. So we'd have minus 1 over 10. Okay, so those use these, remember I used the points, x is 10, y is 10, z is 3, and the point x is 20, y is 10 and z is 2. 2. Okay, so I use those. Alrighty. And we're going to do the same thing to find n. That's the change in z over the change in y with delta x held constant. Okay, so I'm going to use the points 10, 26. And the point 10, 10, 3. So 10, 10, 3, and 10, 10, 10, 3, and 10, 26. So that's like these guys here. Okay, and so m did, so now n is going to be the change in z, so 6 minus 3, and we'll do change in y, which is 20 minus 10, and so we get 3 tenths. Okay. And now we need to find c. Using values of the m and n we just found. And let's go ahead and use the fact that f of 10, 10 equals 3. Right, that's a point. 10, 10, 3. Okay, so I'm looking for c, m, x plus n